So welcome to the video. Today we are going to take a look at how to do a Wilcoxon signed ranked test on version 31 of SPSS. So we're normally going to use this test when we have an ordinal or continuous dependent variable, and when we have a within participants or within subjects independent categorical variable comprised of two levels. Basically that means when we have 2 time points. So for this example we are going to imagine that we are interested in how safe people feel before and after the installation of security cameras in their neighborhood. So in column A we have their perceived safety scores before the installation of cameras, and in column B we have their perceived safety scores after the installation of cameras. So higher scores indicate higher levels of perceived safety. So let's take a look at how to put these data into SPSS. So we'll go over to variable view, and in this name column I'm just going to put before in this top cell to represent before the installation of cameras, and then I'll put after in the cell below. Then we'll go over to this measures column and we'll indicate that we're working with ordinal data in both of these rows. Then we'll go down to data view and we can see that we have before and after now at the top of these two columns. So we're ready to put the data in. So I'm going to select that top left bit of data, then while holding shift I'll click the bottom right piece of data, then I'll go to Command or Control C to copy the data, then I'll select the top left cell in SPSS and I'll go to Command or Control V to paste those data in. Sometimes that won't work, in which case try going to Edit and then Paste, and then that should do the trick. And so once we have the data in, we're ready to run the analysis. So we can go to Analyze and then down to non-parametric tests, then over to legacy dialogues, and then to related samples. We can see that we already have Wilcoxon selected as the default in this window. So if we just select both of these levels of the independent variable and we can transfer them over here using this arrow. It's good to request medians at this point as well, and to do this we can go to options, and if we tick this quartiles box here we will get medians in the output. So once we've done that, let's go to continue and then to OK. So that runs the test for us, and if we look at this descriptive statistics table, we can see that we had a median of 7 for after and a median of 5 for before. So it looks like people tended to feel safer after the installation of security cameras in their neighborhood. But based on these medians, we don't yet know whether that difference is statistically significant, and in order to determine that we have to look at this test statistics table and at this asimp.sig two-tailed row, and we can see that we have a value of less than 0.001, and as this is less than 0.05, we can conclude that there was a significant difference in perceived safety between before and after the installation of security cameras. So that's essentially how we run and interpret the Wilcoxon signed ranked test, but we can also take a look at how we can report those results. So I have an example here, and I've said that a Wilcoxon signed ranked test revealed that perceived safety scores were significantly higher after the installation of cameras compared to before, and each time I've referred to a time point, I've included the medians and n values. So this refers to after the installation of cameras, and we have a median of 7, and as we saw before, that median is coming from this descriptive statistics table and this percentiles 50th column, where we have a median value of 7 in the after row. And we can see that we have an n number here of 15. And then I've just reported the same values for the before time point. And then I get on to reporting these results here. So I've said that we had an z value of negative 3.69, and that's coming from this test statistics table and this z row. And I've just reported this number here to 2 decimal places. And as we saw before, we have a p-value of less than 0.001, and that's coming from this asimp.sig two-tailed row in the test statistics table. And finally, we have this r value of 0.67. So this r value is an effect size statistic, and SPSS doesn't actually provide this to us. So if we want to report it, we have to calculate it ourselves. And to do this, we take the z value and we can ignore whatever minus symbol might be in front of it, and we can divide this value by the total number of observations. So we had 15 people before the installation of cameras, and we had 15 people after the installation of cameras. So we had a total of 30 observations. So if we take these numbers and we put them into Google, it can calculate the R value for us, and it has told us that we have a value of 0.67 rounded to 2 decimal places, and that's the value that I've reported here. And I've described this as a large effect, and that's based on these criteria that Cohen put forward in 1988. He said that an R value above 0.1 can be described as small, an R value above 0.3 can be described as moderate, and an R value above 0.5 can be described as large. And obviously 0.67 is bigger than 0.5, so I've described that as a large effect. So that's about it for the Wilcoxon signed rank test on version 31 of SPSS. I hope that was helpful. If you have any questions, just let me know in a comment and I'll try to get back to you. Thank you very much for watching, and I'll see you next time.